So I have a timer set. So hello everyone, a very good morning, guten morgen and namaste. Today my topic is why Kotlin is becoming my favorite functional programming language. I am mostly the what, why and how person like many of you I guess. So that is what I will be covering today. About me, I am Jayashree S. Kumar, currently with IBM Runtimes team. I am working as Java IBM's classes library developer. I have worked extensively on IBM Java testing before this, and these keep me busy personally when I'm not at work. My relationship with Kotlin started when one day my manager was unable to find a speaker for one of our meetups. He came to me and said, "Jayashree, give a talk on Kotlin." And I was like, what? So, how many here know what Kotlin is? Ah, nice. It's good. For rest of you who don't know, I'll just get into a small introduction. So, Kotlin is a statically typed general purpose programming language which JetBrains created. It's currently open source now. It compiles down to Java bytecode which can be run on your JVM. That, along with its 100% interoperability with Java, is what I believe made the language more popular. It also compiles down to JavaScript, which can be run on your browser in the Node.js servers, which makes this language very versatile for both front-end and back-end developments. It gives a perfect blend of object-oriented and functional programming features. So what then is functional programming? There are many definitions given by many different people. One of the most basic and common definition is programming of the functions. That is functional programming language. It is a type of declarative programming paradigms where what to solve is focused more, in contrast to the imperative types where how to solve is given importance. So functional programming treats the functions as equivalent to mathematical functions, which uses mutable data, which are inherently thread safe, and it is very easier to write, reuse, and test any of these pure functions. By pure functions, I mean if 1 plus 2 is equal to 3 always, then you could replace the expression 1 plus 2 with 3 without affecting any of your other, without affecting your complete functions programs. There is no side effects. So that is a lot useful. Here's a small example of our famous Hello World program written in Kotlin. At a glance, you can see functions are given first class citizenship here. By that I mean you need not define a class to be able to define your functions. Your functions can be defined at the namespace level itself. And optional semicolons, I do not know if it's good or bad, but it's optional. It has done away with the keyword new. You don't see it in this example, but most of the verboseness and most of the boilerplate codes of Java is gone. I'm a Java developer, so my talk will be on that perspective. The types are on the right. This language is also strongly type inferred. By that I mean even if you don't give the type string, with the definition, with the declaration of the variable name, the compiler is able to find, able to identify what type the variable is. It has two types of data types, two types of how you can define your data types, that is the val and the var. These are very important. This is like the modern language syntax. If you define your variable as val, it becomes immutable, read only. By that I mean, in this example, if I try to say name is equal to hi, my compiler will throw me an error saying val cannot be reassigned. There is this var, which is the traditional way how, if you are a Java developer, that is how we have been declaring variables so far. Next, the why. This why is not why functional programming or Kotlin came into existence, But this why is why I'm standing here and giving you this talk, and why you might be interested in going back and getting to know the language better. Functional programming language exists since 1958 when Lisp came out, and since then there have been many great pure functional programming languages like Haskell, OCaml and Scala. But any of you know since when we started talking about functional programming language? Any guesses? Any wild guesses? Okay, from past 5 to 6 years ago, right? Your Lambdas, so I'll be telling that. So I have some of the reasons why functional programming language has caught steam. One, nowadays we have highly parallel multi-core architecture systems which calls for concurrency. If you need concurrency, you need immutability in your code, and immutability is one of the cornerstones of functional programming language. So there we have it. And next is we have better compilers and runtimes. You need not be a functional geek to start coding in functional programming language. All you need to do is get onboarded to some modern language which gives you the functional features, and voila, you can start coding in functional programming. And the last reason I think is because Java got it mainstream, and I might be biased, but I don't think I'm joking. If I'm right, it was in 2014 when Java gave us Lambdas and the Stream APIs. That is when we started discussing functional programming language all over again. The reason being, Java, I would strongly say, still is the most used language. It has accumulated a large developer community, and anything that comes to their notice, it's there. So then functional programming is done. Why Kotlin? It is a modern programming language which has cherry-picked all of the good things from many of the languages around it. It is concise, it gives the users a lot of syntactic sugar and removes the boilerplate codes. It is safe. By safe, I cannot discuss that in this talk, but it takes care of null safety. Your billion-dollar mistake at the runtime, that it takes care of it while you're coding itself with the nullable and non-nullable types. That's for a different talk. Then it has top-notch tools, IntelliJ IDE, where the guys who actually came up with this language, Android system, Android Studio also gives this. This particular language is supported on Eclipse as well, and most of the major build things, Maven, Gradle and Ant, this language can be, your application can use the build system. So yeah, it has lots. And this was my favorite. Being a Java developer, my learning curve for Kotlin was very small, very simple. I just took, after I asked what Kotlin is, I just took 4 hours, start coding. It was the basics, but still, I just got onboarded. It was very good for me. In rankings, since June 2017, when Google made Kotlin its official development language after Java and C++, Kotlin has seen only rise. These statistics I just collected from October 2018, where the popular programming language list, it is 16th rank there. In RedWonk, it is racing from 47 to 27th rank. And Stack Overflow and GitHub conducted a survey for the least disliked programming language, and Kotlin topped it. So like I said, any person, if how many here are from Android development background? Are there any Android developers? Fine. So if at all any Android developer who's gone to Kotlin has loved it, try it later. So there are around 3.4 million apps on Google Play. This Coda is completely written on Kotlin. It's it deals on blockchain, while the big names like Twitter, Netflix and Slack are trying to get some of their portion of their application converted into Kotlin. Okay, that was a lot of what's in whys. I'll jump into the code examples. I'll show you some of the functional features, concepts that I like. Only few, there are lots, but because of half an hour talk, I will jump into it. I'll show you how Kotlin is leveraging it. Lambdas, my favorite thing, because back when Java introduced it, it was so new. There were a lot of discussions and controversies. You can't have functional programming into object-oriented and blah, 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 blah. But still, I started using Lambdas. I liked it. But there were instances when I felt my life could have been easier. In cases where I had to use some exceptions inside my Lambdas, they were kind of pain to me. But when I saw what Kotlin did, okay, Lambdas are anonymous functions that you can treat as values. You can pass them as a parameter, you can return them, or do anything with it as what you would do with any other objects. So here, Kotlin places huge value on its Lambda. Most of the things Kotlin and the Kotlin Android developers are requiring, they do it with Lambda. Every time I see Lambda and what it does, I have always asked myself, where are Lambdas used? I have just given a small snippet for you guys. Lambdas are used when you have to execute a block of code once or multiple times at a later time. For example, if you need to run it on separate thread, or if you need to run it at a specific point in an algorithm like comparison in while sorting, or if you need it to happen in some event, when some event happened, like on click of the link. So going back here in Kotlin, I have the variable double and I'm passing the Lambda expression which takes an integer and it returns an integer. This Lambda, if I hadn't written in the Lambda, would have been a named function, named anonymous function double, that is just written there. That's for later execution. And yeah, and most of the times Lambda expressions, when you use Lambda expressions, you use single parameter. So Kotlin gives you the usage of it. It is very powerful. You just need to tell what to do, and the compiler will on its own get the definition of your Lambda expressions. In this example, it takes integer, it doubles it, and that's what it gives. Next, higher order functions. I'll quickly get that. So higher order functions are functions that take another functions as its parameter, or it will return another functions, and so on. Lambdas are higher order functions, but higher order functions are many more. So in this, func is the function, is a parameter of this higher order function. It is of the type where it takes two integers and gives out one integer. Example of that higher order function is this sum, where it takes two integer and gives one integer. In Kotlin, you can define the higher order functions in two ways. One is by passing the existing function by referencing it, or you write your Lambda within your higher order function. Kotlin programming language as such has no support for higher order functions, but because of its interoperability, it takes the default JDK collections classes, it extends JDK collection classes, and it provides all the features like mapping, filtering, and reduce to for all the standard functional library functions it gives. So in this, the variable number is of array type from 1 to 10. I'm using a filter and I'm using a Lambda which is modulo 5, and my output there here it is 5 and 10, and I'm mapping it to, I'm multiplying it, and I'm getting the output 10 and 20. My last output will be 10 and 20. Okay, I didn't explain that better. We'll move on to the next one then. Closures is another concept where a closure is when your local variable of the function is kept alive even after your function, you have stopped calling your function. We can see this in this example, that will be much better. So I have a closure maker function which takes no parameter, and it returns a function. That is why this parenthesis is there, and that function is of type unit. I mean, it's void, equivalent to void in Java. All I do inside the closure maker is I create a mutable variable num equaling it to 0, and I return a lambda function. Okay, any block of code in Kotlin written in parenthesis are lambdas. So here I'm returning a lambda function which prints a line where I'm increasing the num. So in the main function I have two variables of type closure maker, and I call them multiple times, 4 times of counter 1 and 2. And what do you think the output for this will be? It's a very quiet group. Okay, the output, it begins with, the first time the counter begins with 0, it goes to 1, 2, 3, and then the next time when I call counter 2, it takes 0 and 1, and the last time I'm calling counter 1, it goes back to 4. In this you can see the variable num, each of the counter has its own copy of variable num, but this is a function, it's not a class or an object, so where is it storing it? It's stored in closure. When you start using it in your application, you'll feel it's very cool. Just because I know it and you don't know, you might think, what's the big deal? But yeah, moving on to the next functional programming concept, the extension function. This I really have found it very useful, because here Kotlin allows any class to have any new functionality without having to inherit from that particular class. So here I am extending the functionality swap on the receiver class mutable list. I just do this in Kotlin, I just do dot swap and I write my code, and when I create ABC which is of the mutable type, I will get in my IDE, I'll start getting the functions that I've extended for it. So I could simply use swap, and I'm swapping the indexes 0s and 2s. I'll get my answer 3 to 1. This was that simple. I have used it. It is very nice. I should try. 17 minutes. I have more time. Fine. Currying and compositions. These are more of functional programming concepts that I'm going through. So, like I said, Kotlin is very small and still new. It doesn't have the full support, but somehow the developers thought, even if I don't give it, if someone else gives it, I'm ready to take. So there is this library functionl. It is named functionl. So that library provides all of these functional constructs and patterns to Kotlin, which Kotlin can easily take in. So in that there are multiple things, composition, currying, partial application, and many more. So each time you want to use something, you'll have to use them. So I'll talk about two features. Composition means, where are you? It's okay. Composition means combining two functions to get one function. I have a function add 5, that is I'm having my lambda where it adds 5, and then I multiply the integer with 2, and here I'm composing it. I want multiply by 2 and then add. I would bring that second, and then I would do compose add 5 and compose multiply 2. So what do you think the answer of this will be? Very simple. Give it a try. Sorry? Yes, 25. I'm sorry I don't have any sweets for you, but yeah, 25. So here it takes the output of one function and passes it as an input to the next function in composition. So I give 10 into 2, 20, and then 20 plus 5 is what it will do, giving me 25. This is composition. Currying is it's a concept where you take a function of multiple parameters, n number of parameters, and you split and make it into functions of single parameters. I really didn't find a use for this yet, but I am I'm just 4 months old to Kotlin, so I'm still working. When I find, I'll let you guys know. So here in this function, I have sum to int, where some two integers where I have curried it, so I can pass the parameters separately as different functions. It is like one function is passing it to the other function, and I'm getting the output as integer. That's exactly what's happening here. So I pass 2 plus 4, so my answer is 6. Next, lazy evaluations. I am running short of time, so I'll just skip this. I'll go to the next slide. These are some of the tips if you are planning to start working on Kotlin, and if you are a Java developer. Kotlin IntelliJ IDE, I know for sure gives this. It has this convert Java file to Kotlin tool, which is very good. I have tried it a lot of time. In my Mac, I just go do Control Alt Shift and K, and I have my Kotlin program. My .java becomes a .kt automatically, magic. Then if you don't want to use IntelliJ, and if you want to run it on command line, you do hello world.kt, the extension is kt, and you compile it to get the hello world jar. This is how you do it, and then you execute it using your Java. That Java can be your OpenJDK, OpenJ9, anything that you want. Yes, yes, Eclipse has a support. Sorry? You mentioned about IntelliJ. Yeah. I should have tried on Eclipse. I did try. It works in Eclipse. Eclipse gives it a support to it, but I'm not sure about that tool. I'm going to check. So I've reached my conclusion part. Functional programming is a journey. The more you know about it, the more you understand it and you get comfortable, that's when you would want to stay there. Unless you know, you don't know why you have to use it, you're like, what's that? But yeah, and I felt, in my personal opinion, I felt Kotlin is making my life easier to learn functional programming concepts. After bad time with Lambdas, I just didn't go into functional things, but with Kotlin and how nicely it is giving me all these features on a platter, I went around, I digged into functional programming, and I started seeing why or where, if I use it in my application, it would be better. So that was a big take for me. I am still a hardcore Java fan, so I will never say anything against Java, but because of its massiveness, its 2 decades of accumulated codes, it's very difficult to bring in any new features, any modern features into Java. But when I realized I could use my Java still, and I could start using Kotlin for any of the new functional things, there was no turning back for me, and I'm very happy to use it. I know, to each programmer his own, but still I would urge every Java developer in you, and of course any developers in you, to give functional programming and Kotlin a chance. It is, I would say, we will come out of our comfort zone, and when we try all these things, it is good to know you become more smarter, or I shouldn't say you're already smart, but you will start using them somewhere, you'll start doing things differently, and it's always nice to have a new programming language on your resume. It gives you that big thing, hey, I know 2 languages, or I know 4 languages, or whatever. So yeah, please do go back and give functional programming and Kotlin a try, and do let me, okay, no, do let yourself know. Let's see if the Stack Overflow's least disliked language is still true. So you guys can be the judge for that. Before I say my thank you, I was asked to ask you guys to please evaluate this session. So evaluate it, and thank you. I'm open for questions. Thank you. Yes? Mm-hmm. How about the debugging support for the debugger? Is it intelligent enough to debug such lambda expressions? Yes, it is. Lambda expressions for introduced in Java, that's quite a challenge. Right, right, exactly. I felt the same. But here,
complex lambda expressions which made our life as a nightmare.
I know, I know. So yeah, these tools are very intelligent. I am not gonna market any IDE here, but the IDE that I ran Kotlin on, the Kotlin is very well developed. At least the few things that is out there, it is very well done. You guys should try it. It makes it very easier for you. It's a different experience. So anything that you don't know, you can. I wouldn't say everything is there in this language already, because it is new. Even though it started in 2011, only in 2016 the first application came out, and after that in 2017, after Google told it is good, all the developer community started going and seeing it, and it is your chance to go take a look at it and steer it in the way you might like it. Any other questions? No? Yeah.
As far as I know, Kotlin can compile to Java 6 and Java 8.
Yes.
Is it only a difference in the bytecode or also in the source code?
I never worked on Java 6, and I'll surely find the answer, and I'll be near the booth. By the time I go to the booth, I'll quickly Google it and I'll let you know. I didn't work on it, so sorry. Any other questions? Okay. I think I finished my talk early. Oh, I finished it 4 minutes early. Thank you, guys.